Welcome to LMT Answered in our video on calculating feeds and speeds of our tooling. My name is Martin Trzynski and I'm the tech support and quote specialist for LMT Answered. Probably the most frequently asked technical question we receive is what should be the correct spindle speed and feed rate for a tool. Well, within our catalog we have listed various feeds and speeds charts of our tooling to assist in finding the correct chip load for a given tool. The speed and feed charts are located in the back of our catalog, and there are various different types. Now when I say chip load can be defined as the actual thickness of the chip that is being removed by the cutting edge of the tool. The actual cutting edge, which is located right in this spot. Now chips remove heat that is built up, and by removing heat your tool life will increase and your part finish will improve. For this video we will be using two different of our standard tools to show you how to properly optimize the speed and feed rate for your application. Now the first tool we'll be using will be the standard part number 65-023, which is a single flute. It only has one flute. We call it a Super O flute. Now this tool can be used for several different applications, whether it's plastic, hardwood, softwood, aluminum. It's very a universal tool. Now since the Super O flute can be used on various materials, we first need to determine what type of material you're going to be routing in order to find the correct feed rate and locate the correct feed and speed chart. In this case, let's assume we'll be routing hardwood. Therefore, we'll go to our catalog and we will locate the hardwood cutting data, which is located right here. And what we need to do is, we know for a fact that this tool, the 65-023, is a 1/4 inch diameter tool. So what we need to do is, on the left hand side of the chart we have the tool series listed, and at the very top of the chart we have our tool's diameter listed. What we need to do is cross the two to get the correct recommended chip load. So if we look up the 65-000 series, which is the tool we have, and the 1/4 inch diameter, and we cross the two together, we get a recommended chip load between 4 to 6 thousandths. Now doing this provides us with a chip load range of 4 to 6 thousandths. Since we now have provided the recommended chip load, we need to set the second parameter of spindle speed, which is the RPM, in order to locate and figure out the correct feed rate for your application. For this example, we will just base this on 18,000 RPM. From the formulas also located on the chip load chart page, we have formulas listed underneath the chart. The one we're looking for is the feed rate formula. Therefore, we know the two given values. We know that we have a chip load of 4 thousandths, 4 thousandths chip load. Now we know the RPM will be 18 thousandths, and what we don't know is the feed rate. This is what we need to determine. Now, by having these two values, we can figure out what the feed rate needs to be. Once again, we will be using the feed rate formula. Therefore, the feed rate formula is feed rate equals the RPM times the number of cutting edges that the tool has, and times the recommended chip load. So we now simply need to put in the two given values that we have to find out the third one. We know the RPM is 18,000, and we know the chip load is 4 thousandths. Therefore it's 18,000 now times the number of cutting edges. This tool is a single flute, so times 1, and then times the chip load, which we know is 0.004. Now if we calculate this, we have 18,000 RPM times 1 for the number of flutes and times 0.004, which is the chip load. Now that will equal 72, which is the number you're looking for. That's your feed rate, and that is in inches per minute. So when we calculate this, it's 72 inches per minute would be the correct feed rate for this particular tool running at 18,000 RPM. Now we usually suggest that you run at the lower level of the feed rate and increase slowly until your finish reaches a level that is no longer acceptable. And at that point is reached, you want to decrease your feed rate by about 10%. And then go ahead and start decreasing your RPM by a set increment until the finish deteriorates again. And once again, when this point is reached, go ahead and increase the RPM until your finish is acceptable. By doing this method, this will now provide the best optimal speed and feed rate for the material that you are using. Now, as a second example, we will be using a different tool, which is our standard part number 57-320. This tool happens to be a 3/8 diameter tool, and this tool happens to have 2 flutes. Now this is mainly a general purpose wood route, and once again we'll base this sample and for video purposes we will assume that we're routing hardwood material. So we now once again need to use the same chip load to go ahead and find the different series, which this falls into the 57-200 series on the left side, and we know it's a 3/8 diameter. Therefore, when we cross the two together, we know the recommended chip load is between 6 to 8 thousandths. If we apply the same formula again, where we know the chip load equals 6 thousandths, and once again we will base this on the standard 18,000 RPM, and we don't know what the feed rate is. We once again need to figure this out. Therefore, if we do the formula again like we did in the past, we take the 18,000 RPM, we then need to multiply by the number of cutting edges, which in this case this tool has 2 cutting edges. Therefore we multiply by 2, and we multiply again by the recommended chip, which is 0.006. If we do this, we have 18,000 RPM times 2 and times 0.006. Now that equals 216. Therefore your feed rate would be 216 inches per minute for this particular tool. Now then you would perform the same process of optimizing speed and feed rate as before to find the best finish. Therefore playing with the increasing the feed rate until your finish starts to deteriorate, and then bringing it back down, and then same thing with lowering your RPM and bringing it back up slightly to get the proper and the optimal speed and feed rate. A few also indicate to us that sometimes their machines are not capable of reaching certain feed rates for their application due to the fact that the parts are the parts cut are small in size. Now when cutting smaller parts, we know for a fact that we cannot achieve the fast feed rate because of the short distance of travel, simply because the machine can only advance so fast within that short distance. With this being said, or this being the case, we can always alter the formulas above to find out the RPM if you already know the feed rate you can achieve. Let's use the 57-320 tool, for example, like we did in the past, and let's assume that we are cutting small parts and we can only reach a feed rate of about 50 inches a minute. Well, knowing this, we know that this tool has a recommended chip load of 6 thousandths. Therefore the chip equals 6 thousandths, and we know that we can achieve a feed rate of about 50 inches per minute. What we don't know is what RPM we need to run at in order to get the correct finish and tool life for this tool. Therefore what we can do is we can use the RPM formula that's listed in our catalog if we have the other 2 values to figure out what RPM we need to run at. Simply, the formula is RPM equals the feed rate divided by the number of cutting edges times the chip load. This formula is listed in our catalog to provide you with that. So basically, if we plug in the values, we know that we have a feed rate of about 50 inches a minute, and we need to divide that by the number of cutting edges, which is 2, times the chip load, which we know for this tool the chip load is 6 thousandths. If we bring this down again, 50 being the feed rate, we now have 0.012 as the chip load. And if we do the math, 50 divided by 0.012, now that gives us a RPM of 4,166. Therefore, we know that for this particular tool, in order to get the correct chip load and running at 50 inches a minute, our RPM needs to be as low as 4,166. So now that we know the correct RPM for this application is 4,166, that is the correct RPM in order to maintain the correct chip load, achieve good finish, and good tool life. For any other questions, please visit our website at www.onsrud.com. That is ONSRUD.com. Thank you for listening.